Obviously, this buzzer will run with some kind of sound. So that based upon the sound it is producing, it has been divided as two types. First one is self-driving and second one is external driving. So what is self-driving and what is an external driving? Self-driving. So self-driving means just like you might have heard about of when any one of the car operating in reverse gear. So operating in reverse gear. So most of the cars will get sound kick, 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 like those type of sound will produced by the cars. But nowadays, so these type of sounds are known as self-driving, means the internal components are fixed, the internal music is fixed, the sound which is produced by the car is fixed, everything is fixed. There is no changes at the time of manufacturing and at the time of usage. But some people out of fashion or out of interest, when they are operating in reverse gear, they would like to produce any one of the songs or anthem or words, they can use any one. So these type, if in spite of a regular sound, if they are providing any songs, anthems, words, whatever it is except this one, that particular type of buzzers will known as external driving. So you might have in any one of the latest corporate sectors, software companies, you might heard about of the buzzer sound like only one type of sound only. But if it is in corporate sectors customized versions, then you will get some different sounds. So anyone, if the working of any one of the device under standard conditions with regular music or audio. Regular audio is self-driving, and the same standard conditions with not a regular one. This will a non-regular audio. Either it may be songs, or it may be anthems, or it may be music, or it may be a guitar sound, or it may be a voice over, whichever it is. That's we used to call it as external driving. The next one is push button switch. The name itself, it is expressing when you are pushing the button, then it will act like a switch. That's what exactly it's meant by also. So here I have one of the instrumentation. So this one is my switch button, and this one is my threaded neck, means which will swing my operation from on to off and off to on, and here the corresponding operation has to be performed. So same as like push button switch means it is basically an input device, means depends upon the input only it can act itself. For example, you just press it inside, then it will become, for example, so this is my switch. If it is like this is in off state. If I will press over from top, then this will becomes like, and this is in on state. So depends on the input that you are giving on your push button, and based on that whether it may be in off state or may be in on state. So basically it is an input device, So it will operate on based on two specific operations. So first one is push to make and second one is push to break. So first one, let's go through the first one. Push to make. Make means push to make means, for example, I have one switch. This is my switchboard. So these are my switches. So somewhere around over here itself, I have this is my bulb. Okay. So if I'll switch on this one, then the power supply has to be traveled from source to this bulb and the bulb will getting on. If I'll switch off the same switch, the relation between power supply and this bulb will drop. Okay. The first one, when I am switching on my switch, then the relation or else the relation between the bulb and power supply. There is no relation in between bulb and power supply before I am switching on my switch. So when I am getting switch on, then the relation between PS and PS means power supply and bulb make or established. And then only the bulb is getting light up. And when you are switch offing your switch, then already having one relation or else establishment in between power supply and bulb. But when you are switch offing this switch, then this relation will get break and the bulb is getting off. That's what is push to make and what is push to break. Push to make means normally open the state and it makes a circuit contact when pushed on or pressed. Push to make means it has to establish the connection. Push to break means already there is a connection one connection is established in between switch and bulb. We need to break it out. So simply these are the push button switch circuits. So here I am applying supply voltage as VCC and I am having this one as usual ground. So here this one is my push button switch. Okay. For example, is it in offset or on state now? It is in offset because you can observe the gap in between these two. So this is in off state. Hence, there is no relation between this port pin and ground. Due to this, you will get some output. Okay, that is very low pulse generator. Why very low pulse generator? Why not for high pulse generator will come? Because supply voltage, for example, I am giving 5 volts. If it is 2 kilo ohms, then here I will get around 2.8 volts only, not greater than that one as my output. That is the reason why we used to call it as low pulse generator. Means in between supply voltage to output point, there is one resistor is available. The resistor means which will opposes the flow of current and reduces the voltage which is coming to the resistor as input voltage. The same as if it is come to here, I will just changing the resistor position to here and the switch position to here. Then here this is my switch. So this is my supply voltage, as usual my resistance. Okay. So for example, now it is open, now it is an on state or off state? As usual, off state only. Okay. Is there any chance to get an output voltage? No, because VCC is a supply voltage will not come to up to this extent. So there is no output. But if you give input as 1 or else you just pressed it up, then obviously this will becomes like this. Means now the switch is getting on, right? Right. Now it's switching getting on. So for example, I am giving 5 volts. So here also I will get 5 volts because there is no barrier in between this point and this point, and I didn't have any resistances also. If I do not have any resistance over here itself, what will happen? Then this point is directly shorted to ground. Then here you will get 0 only. But when you have a resistance over here itself, there is some fraction of seconds of time to calculate the output over here itself. That is approximately equals to 5 volts. That may be 4.75, 4.8, 4.9, whichever it is. But when you are comparing with this 2.8, 4.8 is large. That's the reason why high pulse generator. The next one is keyboard. So as we already very familiar with your keyboards, so that's what that you are daily in your regular life that you are using your keyboard. So one space bar, Windows, Alt, Control, Alt, Windows, Control, and here you will get function keys. Okay. So in some of the latest keyboards you will get numbers also over here itself, and the remaining 42 keys over here itself. So entirely it will form 104 alphanumerics. Okay. So by using one particular keyboard, we can give the keys, we can perform the operations of 104. And why we need to use this keyboard? Okay. And most of the time you might be familiar with keyboard is input device. So you can give your input either whatever it may be, either in terms of alphabets. So alphabets means A to Z alphabets are available, 0 to 9 numerics are available. Okay. Next, all symbols, almost all symbols are available, like operational. Operational symbol means parenthesis, division, percentage, cap. So which are already available on numerics, on the top of numerics. Usually we will perform these all operations with shift. Along with shift only we can perform these operations. So this is an input device, means whichever that input has to be given by the user. Any one of the human being has to give the input to the system or to laptop, whichever it may be. Means it is act as interfacer in between human and computer. So this will be the internal structure of our keyboard. This is the internal structure of our keyboard. So I've already told you, by using keyboard we can perform 104 operations, alphabetics, numerics, whichever it is. So there may be a combination of, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So I have in my structure of keyboard around 16 set of keys. So by using these 16 combinations, I need to perform 104 operations. Let it maybe, I'll go for 1 with alphabet A, I'll go for B with second one with B, and C with third one with C. But if any one of the keys combinedly A and B operating, then the outcome will be 1. So just to see logo over here itself. So this entire 16 keyboard can be connected like this. It's just like a mesh. Depends upon the requirement. As an IC, we need to use less space and has to perform more applications. For this particular two purposes, integration will take place over here itself, and then these switches can perform all the keyboard keys 104. And the next one is program peripheral interface. So just I/O capabilities. Any one of the device must and should have to be consisting of input devices and output devices. So for example, if I am considering 8051 microcontroller, it will support up to 40 pins. In this 40 pins, you have 12 input pins and 8 as output pins. Means in these 12 pins, any one of the pin can be used as an input, and in this 8, any one of the pin can be used as an output pin. For example, I would like to extend these pins from 12 to 20 inputs and these 8 to 16 as outputs. Is it possible? No, because 8051 is a microcontroller having a 40 pin only. Then what to do? I can't able to go for one more 8051 over here itself, and I can't able to measure both of them, because how much power is going to be using for this? The same amount of power has to be utilized for this one also. For example, here I am expanding minimum 50,000 for purchasing of 8051 and the internal boards and the power supply connections, everything. Again, I need to spend one more 50K over here itself. Then my financial crisis is going to be increasing. For avoiding that one, I'll take program peripheral interface, PPI. So usually we used to represent with 8255. So for enhancing or improving the I/O capability only, we are using this one. Which one? This PPI, program peripheral interface. As any 8051 or 8086 or 8085, so these are the processors, and 8951. So these are microcontrollers and these are microprocessors. Whichever it may be, they are having very limited I/O support. Which are having very limited I/O support, input and output support inbuilt. For extending this I/O support only, we are using this PPA, program peripheral interface. So this is the structure of PPA. So have a look into this. So I have a data 1, 2, 3, 4, 5, 6, 7, 8. Means it is 8-bit register. So having D0 to D7. So let's start with D0. So D0, what is this port? This is a port, program counter port from 0 to 3. This is 0 and this is 3. Okay? So means PC0, PC1, PC2 and PC3. These are 4 pins. These 4 pins will work. Whenever you are giving 1 as input signal, then it will accept the input, and whenever you are giving 0 as input, then it will releases the output. Means whenever I am giving this PC0, PC1, PC2 and program counter 3, PC3. Whenever I am giving input for PC1, for example, I have considered PC1 and I have given input as 1. Means it has to accept the data. Accept as input. Whichever the data it is receiving, it will accept and admitting itself to represent as input only. But if I am giving input as 0 to this PC1, then it will not accept any data from anyone. At the same time, whichever already having the data by this PCO, that can be represented in output only. It won't accept any input, but it will releases the output. Okay? Same. D0, it can be operated on based on these principles only. Same as either it may be port B also. 1 is input and 0 is output. Whichever it is, in entire group B, if it is 1 means this is input, if it is 0 means this is an output. So, we are having D0 and D1 and D2. Means these 3 register locations will operate on based on whenever I am giving 1, then it will consider as input signal, it will accept the input. Whenever I am giving 0, then it will execute the output. So, same as 7, 6, 8 and this one. Same here also, 1 is an input and 0 is an output, 1 is an input, 0 is an output. Okay? Thank you.